Hello guys, welcome back for another question from the topic matrices, and let's see what do we have today. So we have to compute some expressions, some operations, and let's see. We have a matrix A and a matrix B, and we have to add them. So let me first introduce you with the very important property of matrices, that is, if we have to add two matrices, say A and B, we have to add them, then their corresponding elements are added to each other, that is aij plus bij. Aij are the elements of A matrix and bij are the elements of B matrix, so their corresponding elements will be added for every I comma j that exists. By existing I mean that I and j should exist for both the matrices. It should not be there that A has 9 elements and B has 16 elements. I hope you are able to understand. That means the order of both the matrices should be equal. Only when then the I and J will exist for every matrix, for both matrices. So let me show this with the help of example. Since we have to add these two matrices, this will be added to this, B will be added to B, minus B will be added to B, and A will be added to A. So let's now look into the solution. The solution will be pretty straightforward. A plus A, B plus B, minus B plus B, A plus A. So we finally get our solution as 2A, 2B, 0, 2A. So that's the solution of the first part. Let's move to the next part. This time we have a slightly difficult problem. It's not difficult, just the expressions or the terms or the elements present in the matrix are a bit complicated. But the question is not difficult. We again apply the same property that a square plus b square will be added to 2ab, this will be added to 2bc, a square plus c square will be added to minus 2ac, and finally a square plus b square will be added to minus 2ab. So we perform the expression. This is the first step, and then now we perform. We get our final answer as a square plus b square plus 2ab. This is an identity which can be written as a plus b whole square. Again, this is b plus c raised to the power 2. Again, this is a minus c raised to the power 2, and finally this is a minus b whole square. So that's it. That's the final answer of the second part. Now let us move to the next slide. In this part we again have to perform the addition matrix, and this time the matrix is 3 by 3 matrix, but that does not change the difficulty level of the problem. Still we have to add the corresponding elements only. Let me show you how to do it. Minus 1 will be added to 12, 4 will be added to 7, this 8 will be added to 2, this 2 will be added to 3, and similarly all other elements will be added to their corresponding elements. So we get our final answer as this thing. There is nothing difficult about this problem. We just have to add the corresponding elements of both the matrices. Finally, we have our last part that is not difficult. This time they have included trigonometric functions as the elements of the matrix. So let us see. Cos square x will be added to sin square x, sin square will be added to cos square x, sin square x will be added to cos square x, and cos square x will be added to sin square x. So this is our first step. Now the second step will show you how to add them. So we get cos square x plus sin square x as the only element in all the four terms of the matrix. Now I hope you all remember that sin square x plus cos square x is equal to 1. This is a formula from trigonometric function, which is very basic formula. So we replace all the terms by 1 and we get our final answer as 1 1 1 1. I hope you all got it. Thank you.